Okay, morning Brian. It's really early here still. I'm doing this kind of off the cuff and it's going to be quick and dirty. So you need to create your curve first of all, right? So we need a circle from F4 and the diameter on the circle has to be 8. And then we need a rectangle from center. Oopsie. Wow. I think I might be slightly hungover. Center. F4, the corner is going to be 7 and 7. Alright, so we're going to grab these two, trim them. You might want to just measure your arbor when you get it, but the few that I've worked with so far, this is pretty much the measurement. Okay, essentially this is the curve we're going to work with. Alright. You need to understand a little bit about the geometry of branch arbor and a little bit about how you're going to do flip cuts. Really, you've got a finger size. When you work with a mill, you're going to have to learn to turn your geometry sideways for the flip, which is why the arbor hole is facing this way instead of through finger. But then also you're going to have a finger size in your ring. So let's draw a circle, F4, let's go. So finger size is about, I don't know, about there somewhere. Of course, what's going to happen is there's going to be a hub and there's going to be some spokes. So you can get ready-made geometry hubs. Some programs have them, but they actually limit you more than they help you. When you create a hub pursuant to your own geometry, it allows you to make this as fat or as thin as you want, which means you can go down to finger sizes that are really small. I wouldn't bring your hub section in any closer than say 1.5 mil, because what's going to happen is when you press it onto the arbor, you're going to split the wax. But just for argument's sake, let's imagine that this outer curve is our ring size and this curve over here is going to be our hub area. So let's pop that down over there just to give you an idea of what's happening. Okay. So in reality, I make all my hubs 6mm fat because branch arbor, the little nipple, is 6mm thick. So it just worked out that way. So I'm going to extrude this both sides by 3mm. Okay, so let's show that. So this is kind of what we got in terms of a hub. Alright. I'm going to ask you to use your imagination a little bit and pretend that you can see spokes on there, and this representing the finger size of a ring. So what we're wanting to do is cut a hole through this material so that we can put it onto a hub when we put it into the rotary pass. Of course, you could draw this as part of your ring and actually machine that away. This is not really productive way of doing it. It takes a lot of time in a raster operation while you're cutting a ring to plunge down in there, and so it's simpler to just, I keep this operation that we're about to do now as part of a macro inside my Mac. Speak to Ken about access to the old forum and look for the old Minitech posts, and I've left the screens set over there, or you can just attach this manually into your code, or you can save this as a subroutine over here and import it into all your code. Anyway, irrespective of how you get there, what we need to do is punch a hole like this right through the hub section of our ring. For this, we're going to use a 3.17mm end mill. The reason for that is it fits in that corner really nicely. You can use a 2mm if you want. Makes no difference to me. I use a 3mm because you can punch it through, and a 3mm end mill has a long flute cutting area. So I know on forum I said you go down with a pocketing routine. That's only because I want to keep you safe without getting yourself into any trouble. But in reality, you can come straight in the middle and just do a profile cut. You can push right through and do a profile cut. I like to do 2 profile cuts because where your entry and your exit is, you usually leave a little bit of wax. So let's get cracking on it. Okay, so we know where our geometry is going to be, and we know what our pathing curve is. This represents the outside of branch arbor. Okay, and that's on the ground plane at the moment, because that's more or less where your hub would be. The center of the hub would be when you're cutting your flip. So where we want to go to is we want to look in the 2D section over there, 2.5 axis, and we want to do, I said to do a pocketing, I'm going to say let's do a profiling. Okay, we want to do a profiling cut. The region was selected, it was highlighted, that's why it's showing in there. I'm going to just cancel back out of that. Have nothing selected, and let's start a profiling cut. And there is no region selected at the moment, so let's go select a region, and that's going to be our curve, and press enter. Alright, so we have one curve selected over there. So the tool we want to be using for this is a 3.17mm end mill. Our feeds and speeds, I'm going to manually crank this down in the code just now, and I'll show you how I do that. The clearance is automatic and clearance plane. I'll just leave it over there, not a problem. Now, tolerances here, you cut in a hub hole. You don't really have to be that critical about it, but if you want to just pump that down to 1 micron, I don't know. Alright, now, this always gets me a little bit. Sometimes I have to do it more than once because I can never figure it out. Now, we want to use the inside of this is a closed curve. We want to cut the inside. We want to bring the cutter in and cut around the inside of this curve, not the outside of the curve. Okay. Total cut width is nothing. Alright, so that's great. So let's go to cut levels. Now, there's a couple of ways of getting around how you're going to do the cut levels. Okay. The way that I do it is I actually pull this down to where I need. So I grab that curve, hold the control key, and I pull it down underneath my geometry about there, because I know all my hubs are only 6mm deep. So if I push it down that far, I know that I'm through my material, and I use bottom. So I go the location, the cut geometry is at the bottom. Okay. And I know that the reason I use a 317, as I was saying before, is because it has a long cutting flute, which means if you push it all the way through your wax down to here, you've still got cutting flute on the side, and you'll be cutting through this with the side of the cutter. Okay. Alright, so the cut geometry is at the bottom. Bang, bang, bang. Entry, exit. Don't have to worry about that. And we will arc fit this. I just want to test that it is doing what I'm going to do first. Let's go generate and have a look. So, I'm going to hide this poly surface, and let's have a look at what we're doing. So our cutter is coming straight down the red line. Okay, it's coming, which is a yellow line underneath it because entry and exit's at the same place, right? The line is coming straight down to there. Now you're asking me, why is this offset? Because your cutter is 3.17mm fat, and this line represents the center of the cutter. Okay, so the edge of the cutter is cutting up against that, so it's coming straight in. It's cutting around, and it's exiting. Okay, so all looks fantastic to me. I'm going to go in there and I'm going to edit the parameters for that, and I'm going to arc fit. Alright, simply because I like to use this code. Where are we? Sorry. We want to arc fit on the XY, and should we do XZ? Nah, just go XY. Fitting tolerance 0.01. And go generate. Alright, I'm going to output this code and show you what it looks like. Let's post that code to the desktop. Test. I'm going to call it Arbor. Okay, now let me find Arbor. Okay, there's Arbor. Alright, so now you can see what your code is doing. I know that you don't understand all of this yet. This is header code that's injected because of your post processor. It's telling the mill how we want to talk to it. Alright, MO3 is fire up your spindle. Let's start the code. 2.5 axis profiling is just so on your Mac screen, when you run a Mac, it's going to show you that this is now your subroutine that's running. Okay, then it's saying let's go at full speed to Z1585. That's an interesting looking thing. X. So it's going 1.5 mil above Z. Why? Going down there, J, X. What have I done wrong? Have I done something wrong? No? That is Z1585, so it's going above Z, X. Ah, there we go. It's dropping below Z in the next instruction. So there it's dropping down below the hub at a speed of 400, and now it's going to cut the arc. Alright, so I want to edit this over here because I think pushing down at 400 through wax can be a little bit scary sometimes. It'll tend to pull up a lot of swarf. So let's have a look for that feed instruction. So in that feed instruction, I'm going to back it down to 150 millimeters a minute, and save. Okay, you could have done that inside here, just to show you. There's two ways of getting. I like doing it manually. I like to read my code before I do anything, but that's because I'm a nerd. So you could have just gone in over here and you set your cut feed to 400 and also your plunge to 150 and set your plunge feed to 150. Alright, the plunge is where it comes down. Have a look at the thing. It's the speed the cutter comes down at, and then your cut feed is what it's actually cutting at. The departure and retract wouldn't matter. Okay, hope that's useful to you, mate. But that essentially is that. Cheers.